As we continue talking about geometric transformations, we're going to focus in on translations now. And a translation is a rigid transformation or isometric transformation that moves every point of a pre-image of an object in the same distance and direction to create the new image. As we can see here, as we start with this image ABCD, it's being translated. In this case, you could call it a slide. Many people refer to translations as slides. Looks like it's being slid on the paper down and to the left to A prime, B prime, C prime, D prime. And in doing so, we can see that A maps to A prime, D maps to D prime, B maps to B prime, and C maps to C prime. Now, all of these have been moved in the same direction, which makes them all parallel, actually. So all of these lines are parallel, and they have congruent distances because all of those points move the same distance. So that's just some of the characteristics or properties that we see in translations. Now, as a rigid transformation, it means that the size, shape, and the measurements and the lines and the angles all stay the same, of course. So it still follows those same principles of a rigid transformation. And in looking at this, we can see when connecting the vertices, so line segments, these A to A prime, that's going to be the same length. All of my line segments will be the same length. Each point moves the exact same direction, and then each point moves the same distance. Sorry, I mixed up distance and direction there. So we move the same length, distance, and direction. So as we do these translations, we can look at it think of it as a coordinate plane, and we have a XY coordinate, and we start, and if we have a point on a coordinate plane, it has an XY coordinate location. And then as we do the mapping and the movement, we have this X plus A, which would change the way it moves horizontally or side to side, and then Y plus B, and that would change the way it moves up and down or vertically. So A is the number of units translated, again, horizontally. So we either are going up and down, depending on if it's a positive or negative number, and then we have B is moving it, translating it units vertically. And that is going to be either, I just did that wrong, I'm sorry. Horizontally is from side to side, and then vertically is going to be either up or down. I don't know what I'm thinking. So the function rule may look something like this, where we have a translation, and the coordinates would be A or B. How much is it translated? My X and Y. And then, of course, moving X and Y, and then the mapping may look something like, as I map, I'm going to have my XY is going to map to X plus A and Y plus B. So that is the way that you would see the mapping or the function rule displayed, and this means that we're going to move all X values A, we're going to move all Y values B. The mapping rule says that we are going to add the A value to my X, or we're going to add the B value to my Y. And we'll do a couple of practices here to show that. And it says this example here. So example 1, what is the image of triangle JKL after the transformation of X minus 5 and Y minus 4? And let's see here. So we look, and so we're talking about a transformation. So we're going to move all of our X values are negative 5. So we should be moving them, we're going to go left 5. All our points are going to go left 5, and Y is plus 4, or B is 4. So we are going to move up 4. And again, because this is negative, this is positive, this is positive, this is negative directions. So if I take J and I move up 4, 1, 2, 3, 4, and then I move left 5, 1, 2, 3, 4, 5, J prime is going to be, in this case, it looks like it is going to be negative 3, 5. And I do the same thing with L to L prime. I go up 1, 2, 3, 4, wait, I'm sorry, up 4 and then left 5. 1, 2, 3, 4, 5. L prime is going to be, looks like negative 3, 3. And then K, we're going to go up 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. K, it looks like, K prime looks like it is going to be 1, 4. Okay, so those are going to be the points that I'm going to connect to see my new image. And what I'm going to do now is I just did that on the, I basically used the function rule and did something along the lines I translated negative 5, 4 of x and y. Now if I were to use the mapping rule, let's see, my old j was going to be, or I'm sorry, the old j is right here, and it was the value of, I'm going to change colors here, so let's see here. J was 2, 1. We're going to map that. K was 6, 0. We're going to map that, and then L is going to be 2, negative 1, and we're going to map that. So J prime is going to be mapped to, again, this mapping right here. So we have 2 minus 5, and then we have 1 plus 4. K prime is going to be 6 minus 5, and 0 plus 4. And then L prime is going to be 2 minus 5, and then negative 1 plus 4, which these all map to, of course, these points are going to end up being, doing the math here, that should be negative 3, 5. And sure enough, right here, negative 3, 5 matches up. K prime is going to be 1, 4, and sure enough, that matches up. And then L prime is going to be negative 3, 3, and negative 3, 3, and then that also matches up. So this is finding that with mapping and finding it with the function rule, and then finding it with just graphing, okay? So that's how we're going to do translations. And again, often referred to as a slide because it appears that this thing has just slid this direction. So moving on. What rule describes the translation from the pre-image to the image? Now, everything is moved the same amount. So I only need to find one point and I can calculate that. So if I look, I can look on the graph right here and say it looks like Q. It looks like we have traveled to get to Q prime. The X value has gone from negative 1 to 1. So we went plus 2, and my Y value has gone from 4 up to 5, so it went plus 1. Now, I could say then that we had a translation of plus 2, and I guess I don't even need the plus because we know 2 is positive 1 of xy. Or I could say that it just went, I could use a rule. Okay, I'm using a rule then. If I had xy mapped to x plus 2, and, oops, sorry, having some problems here, y plus 1, that's a mapping rule. And if I wanted to check that, well, I could say that q used to be negative 1, 4, and I mapped it to q prime, which would be negative 1 plus 2, and 4 plus 1, which would map to q prime is 1, 5, and sure enough, that does check out. So there's a lot of different ways to write that mapping rule or to try to comprehend it. In example 3 here, it says triangle QRS has a vertices of these points right here. Okay, the vertices are where my points are going to be, so as I think about my triangle, I could draw a graph, or I could just accept that these are the points, right? Whatever they may be, Q, R, S. And it says, what are the coordinates of the vertices of the image of the triangle after the translation? And they've given me a translation right here. Now, I don't need to put this on a graph. I can just go ahead and do the math here. So I take Q, and that is 8, negative 6. And I am going to map it to Q prime is going to be 8 minus 7.6, because that is my mapping for X. And then my Y value is going to be negative 6 plus 4.3. Let's see here, then R, we're going to map that 10, or it's 10.5, and we're going to map that to R prime, which is going to be 10 minus 7.6 and 5 plus 4.3. And then we're going to take S, and we're going to translate it also to, it starts off at negative 3, 3, and we're going to map it to S prime, which is negative 3 plus 7 points, not plus, minus 7.6, and then we have 3 plus 4.3. Again, so there's my mapping. I can do the math now to simplify. So my Q prime is going to become, my new X value is going to become 0.4, and the Y is going to be a negative 1.7. The R prime is going to be 2.4, and the Y is going to be 9.3. And then the S prime is going to be negative 10.6, and the Y is going to be 7.3. So there are my new, these are my new image vertices of my lunar locations. I did not need to use the coordinate plane, and it would have been very difficult having those decimals to get it exact. Okay. In example number 4, let's see here. Randy draws a triangle ABC on the coordinate plane. They've given us the vertices, and then he translates the figure so that the coordinates of the new images are right here. What rule did he use to draw that image? Well, according to the rules of translations, the distance and direction is the same for all 3 points, so I can just pick one point and work with it. So I'm going to pick A, and A is going to, they told me, is 7 minus 4, negative 4. 7, negative 4. And it mapped to A prime, which would be 7 something, right? And then we had negative 4 mapped to something. And that gave us our original, or our new A prime, which was 5, 1. So what moved? Well, I know that the new value here of A prime is actually, the X value is 5. So how did it change? Well, I have plus some number here, so I have 7 plus, we'll call it A, because A is equal to 5. So if I subtract 7 from both sides, I find out that A is equal to negative 2. So my translation, I actually moved minus 2 on my X value. So that is, the translation rule would have been negative 2. And then I have my Y value, so I have minus 4, and this is some value again, plus B, right? Plus B is going to be equal to 1, and if I add 4 to both sides, turns out that B is going to be 5, so my Y value moved 5. So here we go, I can say that that value is plus 5. So there is my, what rule did you use? Well, we could say that we translated negative 2, 5, XY. because that is how, what did it take for me to go from 7 to 5? I subtracted 2. What did it take for me to go from -4 to 1? I added 5. So that turns out to be my translation rule. All right, so let's see. Now looking here, as we go into example number 5, what is the pre-image of the figure if the rule that created the image was this? Okay, what was the pre-image? So we could turn around and we have to reverse what happened here. This is the new location, and I moved from T, you know, my translation, my old K was plus 7.5 because I moved -7.5 to get here. So in order to reverse that, I'd have to go this way 7.5. And then if I move down 4.1, I would have to move up 4.1. Now we could do that. We could do it with either graphing. I could say, well, I could go, what is this? 1, 2, 3, 4, 5, 6, 7.5, and then go up 4.1, which would be 1, 2, 3, 4, and a little bit more. Okay, that was where my original K was. And then I could probably count everything out and fill those in. I could, and then let's see, where is the rest of them going to be? It looks like something like that. No. Yeah. Something like that right there. And this would be L prime. I'm estimating, but I could turn around and say, well, K prime is -3, 1. J prime is -1, -4, and L prime is -2, -4. And I want to go backwards. And that means I need to go backwards or reverse. Instead of having a -7.5, I need to add 7.5. Instead of subtracting 4.1, I need to add 4.1 because I'm going backwards. So my K values are going to be -3 plus 7.5, and I didn't give myself enough room. Okay, so my Y value, we'll start there. Y value is going to be 1 plus 4.1, and then my X value is going to be 7.5, or -3 plus 7.5. And then as I go to do this with all of them, I'm going to have -1 plus 7.5, and then -4 plus 4.1, and then my L is going to be -2 plus 7.5, and -4 plus 4.1. Oops, I got these two mixed up right here. I got those backwards, my bad. That's what I get for working backwards. J prime is going to be -4, -1, so I have -1 plus 4.1, and then I have -4 plus 7.5. And that allows me to, again, what am I doing? In order to get from where I ended up to where I began, I had to reverse the translation. So it turns out that K is K was equal to 4.5 and 5.1. J was originally 3.5 and 3.1. And then what was the other one? L. L looks like it was originally 5.5 and 0.1. Those were my original values of my triangle right here. So again, we're going to do a lot of practice here, but in many ways it is just determining what was the movement. So we'll get there, and we'll show you a couple of different ways, possibly graphing, function rule, mapping. We're going to find out what works best and what problems for who.